Incorporating an adjustable set of fours for a height adjustable belay line during edge transitions through an artificial high directional. Is it still valid? Is it irrelevant? Does it matter anymore? Is there some dogma surrounding why we use it? Let's just talk about the single main, single belay system through an artificial high directional. During an edge transition, doesn't matter if you're lowering or raising, full 2 kilonewton rescue load or single. The fundamental concept being that if yellow is my main and the red is my belay during this edge transition, if something were to happen with any of the components or the human factor on the main line and it fails, the rescue package will not fall a significant distance. That free fall potential is kept to a minimum. So that's important if you have a loaded litter, you don't want that to run your legs over and cause trauma to your lower legs. So this is better than leaving the belay on the ground during that transition for sure, for that reason. If the artificial high directional were to fail during the edge transition, nothing you can do about that. Everything's going, so you're kind of out of luck. So this kind of mitigates any failure on the main. So we're a little bit more safe by elevating our belay line up as high as we can to match our main line through the high directional on this AZTEK. Now the question is, okay, well, what about when we transition after we've made our transitions or before we're about to make our transition, whether we're coming up or down? Traditionally, we would lower on the AZTEK and drop that belay line as our package cleared the edge. And what that would do for us, if I lowered this down, now my belay line is running on the ground, I should have edge protection, and then the same applies where if any part of my main system were to fail, my belay would catch and there would be no drop because it's already running over the edge, and I keep my free fall distance to a minimum and thus my impact forces to a minimum. So, and then on the flip side, well, if I left this up and I've already made my transition and my operation's well underway, and my rope was still routed through here, if the main line failed, the belay line would catch it, and the frame can handle the forces, no problem. In that respect, it doesn't really matter. However, some people would argue that, well, if your frame failed after you've made the transition and your belay line was still high, then you will free fall further and you'll raise the impact forces in your system, which is less than ideal. And then a third counter to that is, well, why would our frame fail? It's during those edge transitions where the resultant changes, where the potential for catastrophic failure occurs during those edge transitions. And you could argue that, well, if we appropriately guide our artificial high directional, put it through the test of a transition, then we could rationally say that this is pretty safe, and I don't care where my belay line is. I could leave it up if I wanted to. So yeah, I think it's 6s. I don't really know if this is critical. If you've put your artificial high directional through the tests, it passes, it's bomber, it's been rigged correctly by competent people, you could justify just leaving your belay line up. And further, on that note, like, why not just eliminate the AZTEK altogether? The question is this wrong if we just eliminate the AZTEK altogether? Because during the edge transition, we want the belay line high. After the edge transition, if we're very confident in our frame, sure. I mean, you're assuming some risk, but you've thought about that, you've justified it, and you decided that that's okay. So if I see this on a rescue, that's fine. So long as your frame is guided appropriately and there's no way that any results are going to get out of whack where this thing's going to mousetrap over or tip over, then I'd say this is fine too. Also, doing it this way facilitates that 2-tension rope system configuration on the fly a whole lot better. You parallel both your lines at the same level, so really your resultant is true. It's easier to really see that resultant. I'd say single main, single belay during the transitions on a lower and a raise is probably a good idea, probably best practice. It's easier to manage. Once we make the edge transition, depending on the gear we have, we can instantaneously, and I'd say we should, instantaneously just convert modes of operation to 2-tension rope system, especially for a lower. We'll share the tension relatively equally, and as such, the stretch will be pulled out, and then should there be a failure in any one side of our system, any one line or component, the residual absorption for the other line, I wouldn't even call it an impact force. It just absorbs that, and I don't see any kind of free fall potential or any kind of significant impact forces should one of these fail while they're in a 2-tension rope system. On the hull, it's a little bit of a different story depending on the gear you have. Like if we have a winch or something, we're not going to be doing a 2-tension system on the hull. Also, a 2-tension system on the hull really only works well if you have a clean, clear hull field where your both lines are close together, and you can probably you can have your hull team grab both lines and do the hull. Otherwise, it's kind of difficult, especially in terrain that's not favorable if you're kind of doing this in the mountains or the backcountry. A lot of times, like if people try to rig mirrored systems like 2 3-to-1s, thinking that they're going to be pulling equally the whole time, they're kind of kidding themselves. Usually what happens is one team or one puller is pulling while the other person's not, and there's a little bit of overlap. So at any given point in time, you're not truly sharing the load, the tension. It's less efficient. So those are just some considerations when considering to do a 2-tension rope system on a hull. But for a lower, after we've made the edge transition, all day long. In summary, an adjustable height for a belay line during the edge transition, sure. If you forego it, sure. Just be able to justify and explain and articulate why you're choosing to do what you're doing. And avoid rigging something just because it's dogma or you think it's dogma and you see it repetitively over and over. You kind of forget why you're doing what you're doing. So be a critical thinker. And also, there's a video out there, it's pretty good. It was Reed Thorne, DRR, I think it was back in 2012, where they did drop tests through the frame, and they recorded the impact forces, the peak impact forces, and this thing bowed and moved, and it absorbed a lot of energy. And granted, there was an AZTEK in here too, that absorbed energy too, but all that still is transferred to the legs. And you could argue that this frame is capable of withstanding those impact forces should a failure occur of one line or the other after that edge transition. Whether that's a single main, single belay, yeah, it's capable of doing that. But if you're operating a 2-tension system, then you're not going to get those impact forces in a 2-tension rope system if you're operating it correctly, if you're truly sharing that tension. Just a thought.